This is a short description of our project for the AWS Deep Learning Challenge to train a deep learning model on the Habana Gaudi accelerator. What we did in this project, we implemented the Ganilla model that I will explain in a bit. This project was done in a collaboration as a team with Liron Sofer, Dafna Mordechai, and Lior Dagan Leib. So this is who we are. We worked together on this project for quite some time. What we implemented is a paper of a model named Ganilla. Ganilla is an image-to-image translation, solves the image-to-image translation problem, which means that it's a set of problems where we take one image and we want to do some manipulation on it. In this particular case, we took landscape images, like the original paper took landscape images, and transform it into the same image with the same content, but with the style of some illustrator. When the paper was out, it was a cutting edge in this field, and you can see here that it has some really amazing results. So technically, after you train a model with data set of a specific illustrator, you get this machine, the trained model, where it knows how to imitate a specific illustrator. So here, for example, you can see the Sea of Galilee, a picture. And when you answer that to Ganilla trained on Miyazaki images, you can see that the output preserve the same content, but get some different coloring that are more Miyazaki-like. It is a really complex model, actually. It's not a simple one, it's a GAN. And it has a few different concepts that we're not going to talk about now, but it does contain a few different modules, actually, a few different neural networks that are working together. One important concept is cycle consistency, and another is preserving the identity loss. It's not detailed for this project, but just in general, just to show that there's a lot of thought that was when this model was created. These are some results where we implemented it even before this challenge. You can see the input images on one side and Hayao Miyazaki style on the other side. You can say somewhat Hayao Miyazaki style. You can see that some of the coloring really changes, but all the content is preserved pretty nicely. What we wanted to do for this challenge is to take the same model that we already implemented on NVIDIA machines and implement it on the Gaudi accelerator. And we took the model and did all the adaptations that are needed. We wanted to use a different type of data sets, and we also wanted, we needed for them to be on the public domain. So we found an amazing data set by the Metropolitan Museum that is on the public domain. And for the actual images, we kindly received pictures from Merav Ben-Yitzhak that allowed us to use her own images for this challenge. We also wrote a bit about it, so if you will look on it online, you can see exactly what is the module and what we implemented, and everything obviously is open on our GitHub. Thank you for listening.